For over a century, air warfare has been a contest of detection. Whoever sees first, strikes first. Whoever remains unseen, survives. From the earliest biplanes to supersonic jets, the skies have always favored the aircraft that could hide longest. Modern warplanes are no longer designed merely to outrun or outgun the enemy. They are designed to vanish, to exist in the sky without appearing on radar screens, to fly through heavily defended airspace without ever being acknowledged. This is the era of next-generation stealth, and it is redefining air power itself. Stealth is often misunderstood as invisibility. In reality, it is about deception, about controlling how, when, and if an aircraft is detected. Radar, infrared sensors, satellites, and electronic surveillance all work together to track aircraft. Modern stealth warplanes are designed to defeat all of them at once. This is not achieved through a single technology, but through a layered system of design, materials, electronics, and artificial intelligence. The story of stealth began decades ago, when engineers realized a simple truth. Radar does not see objects, it sees reflections. If you can control how radar waves bounce back, you can control what the radar sees. Early stealth aircraft were shaped like sharp, angular sculptures. Flat surfaces and carefully aligned edges scattered radar signals away from the source. Engines were buried deep inside the fuselage. Weapons were hidden internally. Even the angle of a panel could determine whether an aircraft appeared as a massive target or a faint echo. These designs worked, but they came with limitations. They sacrificed speed, maneuverability, sometimes even stability. Pilots relied heavily on computers to keep the aircraft flying. Stealth was powerful, but fragile. Once detected, early stealth aircraft had few defenses. Next-generation stealth changes that balance. Modern stealth warplanes are not just passive ghosts. They are active manipulators of the electromagnetic battlefield. Advanced radar-absorbent materials coat the aircraft's surface, converting radar energy into heat instead of reflection. These materials are lighter, more durable, and adaptive, capable of responding to different frequencies. Infrared stealth has become just as important. Jet engines produce enormous heat, making aircraft visible to thermal sensors and heat-seeking missiles. Next-gen designs use advanced cooling systems, shielded exhausts, and airflow manipulation to reduce thermal signatures. Some aircraft blend engine exhaust with ambient air before it leaves the airframe, masking heat trails entirely. But the greatest leap in stealth is not physical. It is digital. Modern warplanes are packed with electronic warfare systems capable of jamming, deceiving, and confusing enemy sensors. Instead of simply avoiding radar, they can actively manipulate what radar sees. False targets appear. Signals are delayed. Entire aircraft formations can be digitally disguised as weather patterns or background noise. In this new form of stealth, the aircraft does not hide, it lies. Artificial intelligence now plays a central role. AI systems analyze sensor data in real time, determining the best flight path to minimize detection. They adjust emissions automatically, deciding when to remain silent and when to overwhelm enemy sensors with electronic noise. Pilots no longer manage stealth alone. The aircraft thinks alongside them. This evolution has transformed air combat. Dogfights between pilots are becoming rare. Instead, battles are decided long before aircraft see each other. Detection ranges, sensor fusion, and data dominance determine outcomes. The aircraft that remains unseen longest controls the engagement. The United States has led this evolution for decades, developing stealth fighters and bombers designed to penetrate the most advanced air defenses on Earth. These aircraft are not built to dominate the skies openly, but to strike precisely and disappear before retaliation is possible. China has rapidly advanced its own stealth programs, focusing on long-range detection denial and regional air dominance. Its next-generation warplanes emphasize sensor fusion, electronic warfare, and integration with space-based surveillance. Other nations are following. Europe, Russia, and emerging powers are investing heavily in stealth research, understanding that air superiority in the future will belong to those who control perception itself. Yet stealth is not absolute. As stealth aircraft improve, detection systems evolve in response. Low-frequency radars, quantum sensors, and networked detection grids attempt to spot what traditional radar cannot. Instead of relying on a single sensor, Modern air defenses combine radar, infrared, acoustic, and satellite data to build a composite picture. The result is an invisible arms race. Aircraft designers reduce signatures further. Air defenses adapt. Each advancement forces the other to evolve. Victory becomes temporary. Superiority becomes fleeting. This constant escalation has pushed stealth technology into new territories. Adaptive camouflage is no longer theoretical. Experimental systems aim to alter an aircraft's electromagnetic and visual signature dynamically, responding to threats in real time. In some concepts, the aircraft does not have a fixed stealth profile at all. It changes continuously. Future stealth warplanes may operate as command nodes rather than lone fighters. They will coordinate unmanned drones, extending their sensor range and offensive reach while remaining hidden themselves. A single invisible aircraft may command dozens of autonomous systems, striking from multiple angles without ever exposing itself. The pilot's role is changing too. Stealth aircraft. The human becomes a commander rather than a traditional pilot. Artificial intelligence manages flight stability, sensor processing, and threat avoidance. The pilot focuses on decision-making, strategy, and mission execution. Some designs remove the pilot entirely. Unmanned stealth aircraft can endure higher stress, fly longer missions, and take greater risks. Without a cockpit, designers gain more freedom to optimize shape and signature reduction. These aircraft may operate silently for days, observing, mapping, and waiting. Stealth is expanding beyond aircraft alone. Satellites, missiles, and even naval platforms now integrate stealth principles. The sky is becoming a layered battlefield where visibility itself is contested. Seeing no longer guarantees understanding. Detecting no longer guarantees targeting. This has profound strategic consequences. Invisibility creates uncertainty. Nations cannot be sure what aircraft are present, what missions are underway, or what capabilities are deployed. Deterrence becomes psychological as much as physical. The mere possibility of invisible warplanes overhead can alter decision-making, but stealth also introduces risk. When detection fails, miscalculation becomes more likely. An unseen aircraft may be interpreted as an attack too late. Escalation can occur without warning. The margin for error shrinks, and there is the human factor. Pilots flying invisible warplanes operate under immense pressure. They trust machines to keep them hidden. They rely on data they cannot visually confirm. A single software error, a single miscalculation, can expose them instantly. Stealth does not eliminate danger, it concentrates it. As technology advances, the sky grows quieter, but far more dangerous. The absence of visible conflict does not mean peace. It means the battle has moved beyond sight. Future wars may be decided without air battles ever being witnessed by the public. No contrails, no explosions on camera. Just outcomes shaped by aircraft that were never seen. The invisible warplanes of tomorrow will not announce their presence. They will not seek glory. They will simply arrive, accomplish their mission, and vanish back into the darkness. And when nations ask how a strike succeeded, how defenses failed, or how airspace was breached without warning, the answer will be the same. They were never meant to be seen. This is WarTech Frontier. And this is the age of invisible air warfare.